All right, we're talking about natural logarithms. What's a natural logarithm? Well, let's not get into too much detail just yet. Let's just talk about this number, this magic number called e. And we get to deal with e a bit. Okay? And e is referred to as the natural number. Okay? Now e is going to pop out when you start doing limits and various other things, and leaves us natural. E is this natural occurring number. I'm not going to get into where it comes from or how we derive it just yet. I believe you get to do that in 111 anyway. All right, but e is always associated with an exponential. Okay. So on your calculator, oftentimes, depending on which calculator you have e to the x, or you've got e caret something. Okay, because whenever we're dealing with e, we're talking about exponentials. Okay, so that's where it pops out at. So if you want to know what e is, because e is just a number, okay, well, any number to the power of 1 is itself. So when we plug that in, okay, we find out that e is approximately 2.718. Of course, continues on. Usually only go 3 decimal places. All right, and there's going to be also this other new term called ln, which is the natural log. Okay, and we use ln, or we use the natural log, when we're dealing with the number e. Okay. Now remember that if you've got log some base of a that equals an x, well, we're talking about the same thing here with the natural logs. It's just like another log. So you know how the base of a log varies, you know, maybe it's 10, maybe it's 7, maybe it's 6, whatever. Well, if you've got log base e, okay, in other words, our base is an e, so if we have something that looks like this, e to the x equals a, okay, that e is just our base. It's just the base that we're talking about, okay? But we don't write log base e, we write it like ln, the natural log. All right, so let's talk about why this is handy and bring up a few instances here of when and where we want to use this. Okay, so let's say we've got this e to the x that we're going to be solving for, and well, it turns out that if you take the natural log of e to the x, that's going to be equal to just x. Okay? Put parentheses around that. So in other words, taking the natural log of an exponential with the base of e cancels each other out. Right? The same is also true if you've got the natural log of something. Okay? What you can do is you can take e, okay, and put the ln of x up in its exponent, and that's going to be equal to x. So again, the e and the ln of x cancel out. Let's do a problem quickly here. Alright, so let's say we've got e to the x equals a 50. We want to know what value of x makes this a true statement. So what I'm going to do is I'm going to take the natural log of both sides. Because when I take the natural log of e to the x, I'm left with just the exponent. So that leaves me with an x. I take the natural log of 50, and I see that x is approximately 3.912. And plug that back in and check it. Alright, now let's say I'm taking the natural log of x, okay, and that's equal to a 2. Right? Well, what I do is I take e to the power of ln of x equals e to the power of 2. Right? See how the bases are the same? So it's got to be equal up there. And again, it turns out that e to the natural log of x cancels each other out, so I'm left with an x. And that x would be equal to e to the second power, which is approximately 7.389.